So initially, I was intending, as you know me, to deliver a very proper formal presentation on breaking and securing cloud platforms, and then lockdown happened, right? So instead of me actually flying to Amsterdam, I'm doing this remotely. So I lightened up my slides with some sketches. Hopefully, if you find the way I'm talking boring, then you can probably at least enjoy the sketches. So roughly, a quick introduction. I'm a security researcher with Thermicro, based in Taiwan. I've been around HTTP for quite a while. I think probably 2005-ish. I broke quite a few things during HTTP, before HTTP, and after HTTP, which I would not like to mention. I speak Russian, speak Chinese. One thing that is particularly helpful during the lockdown is being a doctor. Unfortunately, I'm not that proper doctor, but we have two doctors in our team, so we can still work through. Another thing you might notice that on the screen I have this TLP green thing, because initially I was preparing a presentation not to be like, to include some details which I would like to be shared within certain community. But since we broadcasting, I changed TLP green to TLP white, so you will see TLP green through all of the other sites. Just ignore it. It's TLP white. So feel free to take screenshots, share with your friends, play around, and so on. So agenda. So roughly what I'm going to talk about. So I'll briefly introduce what are the cloud platforms, what the cloud platforms are there. We'll talk a little bit about different types of attacks that we've seen in a while. One of the things which I wanted to do within this presentation, I wanted to focus on a defender view. So I'm mainly interested on those low-hanging fruits, the attacks which actually you would observe happening against cloud platforms via the theoretical kind of things. If you would be going into theoretical attacks, there are lots of other things to look into. And one of the previous presentations was talking about attacks on containers, a pretty good one. So I'm trying to mainly cover all of those low-hanging fruits here. We'll briefly look into cloud underground and how attackers are dealing with cloud as well. And I have a winner for this presentation as well. So what is cloud? In my understanding, cloud is this ephemeral word that defines something that is not anything. It's basically when you use computing resources or storage resources of someone else's computer, that's basically a cloud. So it's been heavily pushed by different companies as a marketing gimmick, but it's basically they let you run your software on their computers. So cloud is indeed a complex thing. And I think it gets more and more complicated by day. Just out of like random, I was browsing Twitter when I saw this tweet, which basically explains how complex like instances of different cloud platforms are. That's my favorite tweet. And what are the prominent clouds out there? So of course, Google Cloud. If you look into amount of like services provided and usage, Google probably is taking a huge part of it. They provide like lots of services. Microsoft Azure is also a cloud player. And of course, Amazon. Amazon has over like 150 different services which they provide. And think of it, if you're a cloud user, you have to understand all of those services. You have to understand how the services are specifically used within this particular platform and be able to properly configure it. So I believe a lot of problems that are coming in deployments of like cloud-enabled systems are coming from complexity and users not being or not even having time to fully understand the whole complexity of like protocols, policies, roles, and so on. And there are, of course, all of the other smaller cloud players out there as well. Like even IBM has IBM Cloud, Alibaba has Alibaba Cloud. In Taiwan, we have local telecom that has a cloud solution. So every other company is trying to because it's a hot market basically. So as the hot market was heating up, you probably would notice that the news posts which are related to the cloud platforms also start popping up, like data being leaked, data being stolen. In fact, if you analyze a lot of those issues, you could narrow down it to like a few um, root causes. And I think the main reason is that cloud systems actually are more complex than like dedicated servers. You have to understand what are you using in order to like use it properly. Facebook used to have this motto saying "move fast and break things." That's basically a big no-no if you're using cloud platforms. You can move fast. Cloud is actually enabling you to move fast and break things, but you have to be careful and you have to understand what you're using, because you're getting lots of tools with lots of features. If you're not disabling things that you don't want, other people might find it and use that. So I think to some extent there is a conflict between this DevOps, fast, rapidly growing business kind of thing, and properly securing cloud. Like when you secure a cloud, you need to step down and analyze things like with cold blood and yada yada. So if you look into a typical cloud deployment, you can think of it as an iceberg, and only the small thing on the top, like a piece on the top, is something that you control. There is a lot of underlying infrastructure in many cases which you might not even be aware of, that A, you don't control, and B, maybe you can't even secure yourself. So when you look into vulnerabilities in cloud platforms, you roughly could break them into two things. A, the mistakes that are being committed by the user of the cloud technology. So there is a way to secure things, but maybe you didn't know about this and you didn't do it right. Or there is actually a vulnerability in the actual software that the cloud platform is using to provide you a service. And in this case, you have nothing, no other option but like filling in a ticket and waiting until they fix this. So let's start with the first like vector of attacks on cloud is data access on cloud. Like obviously many people store data on cloud, and data is probably one of the valuable things that many of the organizations have. So out of the data storages, S3 bucket is probably one of the popular ones, and that's where the data is. And for many organizations, that's like core of their value. And over these years, we've been seeing that the S3 bucket has been bleeding and leaking data as well as others. So here we'll use the one of the recent incidents in LA Times website as an example of why S3 buckets leaking the data and how they are being compromised. So there was a news basically saying, oh yeah, we noticed that LA Times website was having a crypto miner installed. So basically you open a browser, go to LA Times website, and it starts crypto mining JavaScript inside your browser. While you're browsing the website, it uses your computational resources to produce crypto codes. So the guys also were well aware of what cloud is, and they were efficiently using someone else's computers. So if you dig deeper into, like in this particular case, deployment of the LA Times website as well, you will notice that if you query the website, you will see HTTP header that basically says that this website is hosted on platform. There are like other ways how you can realize this. You can just take the IP address to who is on that, but maybe they have like another front-end proxy info, you know. But through so there are multiple tips which could tell you that the website is hosted on AWS infrastructure. And the proper way of doing this is having a CDN-like service called Platform in front, and this platform service would be taking data from a S3 bucket and showing it to the user through like HTTP protocol. Unfortunately, that's not the only way how to like make your data available over HTTP. There is also a conversion exists that you could simply make the S3 bucket data available over like HTTP format URL. And a lot of users, as we noticed, they simply misunderstand security issues with that and misuse the technology. So in case of LATimes.com, there was a website dedicated to homicide statistics. Like if you do curl on that, you will see that there is a cloud from here. From here, you basically know that this website hosts at least like part of its infrastructure on Amazon. You might know the S3 bucket here, but that's basically another challenge. And guessing S3 bucket is probably in many cases it's as hard as guessing the domain name or subdomain name of an organization. So, and the good thing for the attacker, of course, is that many of the tutorials actually they don't suggest you to pick up an S3 bucket that has a secretive name, because it will be security through obscurity, obviously. They suggest you to use something that is related to your domain name, so you don't, your S3 bucket doesn't clash with other users of the service. And so by trial and error, you could actually find even if you don't see the reference to the S3 bucket within the web page, you can actually guess it. In many cases, we've also seen users simply referencing to the HTTP conversion of the S3 bucket notation. You can just extract the S3 bucket name directly from the URL. So how do you find out whether this website has an affiliated S3 bucket? So there is this website called helpsites.de. You can use command line AWS tool. See, hey, do we have a S3 bucket called 2019 helpsites.de? Yes, we do. And the thing is, the conventions for the domain names, like which characters you're supposed to use, the lowercase, applies basically to the S3 buckets as well. So you have limited number of characters that you use. So even if you were picking up S3 buckets as a password, it had to be like a very complex phrase. And we have not seen any of tutorials that actually recommend this. So one thing that you don't want to see as owner of the website or as attacker, actually you would like to see, is when you get ACL, when you list ACL access of the S3 bucket and you see permission full control. That means that you can download files to the S3 bucket, you can upload files to S3 buckets, to all of those things. And what was interesting, we thought since S3 bucket thing got hot and popular, it's been over a few years, we thought the thing disappeared. But when we run a search through some of the telemetry data that we had access on, we noticed there are a lot of websites which actually are partially using like host some of their content on AWS S3. So there are banks, there are online shops, there are travel agencies, like lots of organizations. They might not host the whole site on those content, but they would normally host some of the content which they frequently change. So there might be images on S3 buckets, there might be JavaScript, maybe parts of the HTML code. And I think what is lacking here is the common awareness that once you host that stuff there and you misconfigure access permissions, you will, like attackers would be able to run code of their will on visitors of your websites. That's probably what they don't realize. So we scripted like a quick mass scanner, non-intrusive. So we didn't actually write the things. We used other techniques to see whether the buckets were writable. And as of like end of last year, we found like quite a bit of buckets still readable, which are related to some websites out there, and quite a few buckets still being writable. One of the things that we noticed as we were going through the data sets we've seen lots of other people's files inside those 3 buckets. So those open buckets were just like garbage cans. And one of the files we've seen was the file from Random Robbie as well, normally named poc.txt. And he claims that he left copies of his file on over 5,000 different buckets. This is an example of one of the S3 buckets that we've seen last year. You can see there's like lots of garbage here. There is a bug disclosure, there is a POC, there is test upload. So it's a problem that is actively being exploited or played around by both white hat and black hat community. And the problem is still out there, even then we've seen more than 4 years that people have been discussing this issue. So what happened in context of the homicide LAtimes.com? So attackers basically modified one of the JavaScripts, and they appended a minor JavaScript version to a JavaScript. So anyone who will be loading the website would also be loading the minor as well. So it's extremely important to check permissions of these 3 buckets when you use them. Because that was one of the scenarios, minor. Maybe some of the website owners say, we don't care. We don't lose money on this. Some of our users mine some crypto coins, so what? We actually have seen other users of writable 3 buckets as well. In this example, it was online shopping website where a file called API was uploaded. Apologize, I have a cat here which also attends my presentation. So API.js was uploaded, and the content of the API.js had a very simple snippet of code. It basically would go through all the values. So whenever you hit submit, it would go through all the values of the forms and will base64 encode those values as a JSON blob and send it to the machine that the guy owned. And this way, he was basically scrapping information from the website. We looked through some of the logs, and that's roughly what we normally see in those logs. If you decode this thing, you could actually see that the guy was harvesting credit cards and basically exploiting the same issue. This thing actually is getting more and more popular among certain groups within the underground. We've seen people actually selling packages of web skimmers. That's just one of the examples. So what else is possible when you find an open S3 bucket that is hosting content for a website? You could be creative. Like there have been tons of presentations of running a browser botnet or owning bad guys with a JavaScript, yada, yada, yada. So all of that content could be actually reused as additional steps of exploitation in this context. There is also a variation of this leaky S3 bucket exists when permissions of an S3 bucket could be set properly. So not everyone would be able to read and write from the bucket, but an attacker might be exploiting an reflection kind of attack. For example, server-side request forgery. So whenever you build your infrastructure on Amazon, you normally would have some of Amazon instances, which would run with your work with your data that is normally stored inside S3 buckets. And then you would have probably some sort of front end that maybe platform that is serving your data to the customers. So in this case, if your EC2 instances are exposed, and either attacker can compromise the EC2 instance or manage to exploit some sort of reflection attack. And what I mean by reflection attack is if he would manage to bounce off that machine and send HTTP request to a URL of his desire and get the response, he can still gain access to S3 buckets. And that's what happened in one of the incidents with Capital One, which I think happened last year. The news was basically saying, without much detail, that a former AWS engineer arrested over massive Capital One leak. So what actually happened? Amazon has this a very interesting feature that when I learned about this feature, I found, whoa, I didn't know about this. So there is a link local address available, and you could talk to this address and get additional information. So whenever you create an EC2 instance, your EC2 instance could be bundled with additional permissions. So you could assign a role, and when you execute your EC2 instance, the code that is running on this EC2 instance would be able to assume the role and then access other parts of the infrastructure that is hosted on the cloud. So, for example, if you're using Amazon EMR, my Amazon EMR needs to access S3 buckets to the data mining and stuff. Those buckets are not public, so I need to assign a role to my EC2 instance. So when it starts, it would be able to read data from the S3 bucket. So to me, transparently, like I don't even see how this happened. So I just use the Amazon provided API in either my Python code or my Java code, and this happens on the background. But what happens, in fact, is that the API framework is issuing a request to link local address, obtains authentication token, and then it will use this authentication token to authenticate itself when it talks to all of the other resources. That sounds like a perfect design, right? But what essentially this means that if someone is either able to compromise this machine or is able to bounce like a URL through this machine, they would be able to get this authentication token as you see on my screen. Like you just run curl on this IP address, this URL, you get a token back. Then you can basically take this token and you can access lots of other things. You can check what's the OpenSSH key configured with this particular instance. You could get all the additional configuration details, and of course you could take this token and use it to authenticate yourself when you access S3 buckets. So if you hear a news that an organization had their data leaked through S3 bucket, it does not necessarily mean that the bucket was having word-readable privileges. It also means that bucket was just out there, and somehow the guys managed to get the token. And there are other things or these hidden gems within the AWS API which might be worth exploring. If you go and search for XAMZ credential exploit, you'll see like a lot of issues existed in the past around handling this properly as well within different services. And as Amazon grows, I believe it's still an open surface to explore. I have not been doing pen testing against Amazon itself, and without legal authorization, I don't think it's a legal action. But if I were to do pen test against the Amazon infrastructure, that's where I would look. That's where likely mistakes might be committed both by either the cloud technology users or the service provider itself. So Amazon actually provides a mitigation against this issue, but of course it will come at expense of convenience. So if you don't need to talk to this magic address, you actually have to have IP tables configuration on your box disabling connections to that thing. So how else would you be able to compromise cloud infrastructures? I think people have been talking about Google Docs quite a bit, and I think hacking cloud systems is also possible just with Google Docs. Just remember, we mentioned this motto by DevOps: move fast, break things, right? So, and a lot of systems exist around cloud deployments, which actually allow DevOps to move fast. But DevOps, when they move fast, they forget a very essential thing. They forget to take care of the security and privacy of their data, either configuration files or deployment files. And in this particular example, Amazon has this a feature called CloudFormation. And what essentially CloudFormation is a YAML script where you describe how your Amazon infrastructure gets deployed. What is interesting that those CloudFormation scripts include lots of sensitive information, including what's your oops, sorry about this, including your security group policies. So which machine is allowed to talk to which machine over which ports. So when I was doing pen testing in my early days, we would spend hours and days port scanning the targets, trying to understand what their firewall security policy is. Now, since when you have this cloud infrastructure, this is actually a great time saver. You don't, if you're lucky enough to find their security policy online, you don't need to scan. You already know which ports they open, what are their trust relationships, and this, I believe, highly speeds up the exploitation process. Other cloud related platforms like Kubernetes also have similar things. You could simply search for kubeconfig, and kubeconfig things have very interesting things. In early days, kubeconfigs, Kubernetes did not require any authentication. Later, they started requiring authentication, but in kubeconfig, you could find things like client certificate that is used for authentication, and I think that's basically crazy. Like when people forget and commit those things on GitHub, and I think from the attacker point of view, GitHub is one of the interesting platforms that leaks so much data that I've seen some people just consume GitHub feeds just looking for sensitive database. So what is the root cause of all of this? We believe that one of the root causes is that many of the tutorials on cloud technologies are written by engineers, not security aware people. So they recommend lots of bad practices just in their tutorials. And of course, people who learn cloud technologies, they're going to copy information from those tutorials. So for example, your credentials in plain text in Python scripts, that's bad. Like you committed to GitHub and your Amazon credentials are gone. Next 20 seconds, someone will start creating these two instances and start mining coins at your expense. What I also have seen that there are other tutorials where they also recommend to put the same keys as a part of HTTP page. That's, I think, plainly not really wise, because seeing the source code of the HTTP page is a non-trivial task for like even a beginner's pen tester. And credentials are like everywhere. You look into Pastebin, you look into GitHub keys, like you could specify particular patterns, like lots of them, like all over the place, just like a garbage. So the next thing, we've seen that the data is very leaky in the cloud, but cloud is basically about both providing the data storage and the execution capabilities, and it's as likely possible to execute your code on the cloud infrastructure itself as accessing the data. So we'll briefly look into containers. So one of the previous talks was about Docker. There is also other container platforms which more or less are based on the same technology. So there is Kubernetes, there is Apache Mesos, there is Amazon Fargate. There is quite a bit of that. So Docker, me as a incident response person, I've seen attacks on Dockers for quite a while, and a lot of them that were like very silly, very straightforward. So first of all, it's not recommended to expose Docker admin API over the internet. If you read system logs, it's not recommended. If you read documentation, it's not recommended. But if you look into like platforms like Shodan, exposed Docker instances are all over the place. Like you can search for them. You can even use Google Docs to search for URLs of the machines hosting Dockers, and this widespread presence of exposed Docker instances made things like cryptominer infections very widespread among Dockers, and we've seen either a they would deploy just the scripts with the crypto miner code, and we also have seen they would have templates which would they use as well. So what we've seen, like in one of the instances, they would host a script on Pastebin, and it would be just a script that would be mass scanning internet for exposed Docker instances. If they find one, they will create an instance and execute the code. So they interestingly they also leave a message to the users that there is no malicious intention involved. Just want to mine coins on the machines. In other instances, we also have seen people deploying DDoS tools, so they would be running a DDoS botnet on those documents as well. But why is this happening? So during one of the incident response cases, I actually looked into the log file, and the log had this message for 2 years before this Docker instance was compromised. So it says, don't bind on any IP address without knowing what you're doing. So it says you have to know what you're doing when you open the port to the public. And obviously, a lot of people who use Dockers, they probably don't even read logs. So what we've seen that hacker did, he discovered this machine. This machine was basically exposed for 2 years before he discovered this machine. But what he did, he issued a request, deployed his Docker instance. In this case, it was not a coin miner. In this case, it was a DDoS botnet. Yeah, just like that. So Kubernetes. Kubernetes sounds on a paper by design. It sounds a very well designed, well thought platform. Authentication involved, other things. It requires a client certificate by default, which you still, however, might be able to find on the internet as well. But the interesting thing is, so is Kubernetes secure? And unfortunately, not so. Early versions of Kubernetes did not require authentication, and there are 2 ports that exist on a Kubernetes deployed platform, which allow you to read and communicate with Kubernetes machine. So if you look for Kubernetes, lots of instances around the internet still have those ports exposed, running older versions of Kubernetes, and those ports just bleeding the data. So you could see all the system configuration, you could see what's running on the machine, you could also execute things. And there is another service on Kubernetes called etcd, which is basically like a zookeeper that like a storage for information. And there are, like, if you look into Shadon, there are a lot of machines which still have that service exposed. You connect to that, you get all of the system information, what's running there, and who knows, maybe some application designers decide to store the passwords on this platform. You might be able to find the password as well. So with this, let's look how attackers are masquerading as a cloud services. So since clouds have been getting so much popularity in enterprises, attackers have been obviously paying attention to this popularity as well, and they realize that if they masquerade as cloud services, it's much harder for them to be detected. What is interesting is that many of the organizations, if they see, for example, IP ranges owned by Microsoft, they simply whitelist it, because otherwise it would be endless number of false positives that they would have to deal with. So this is actually my question for you. If you see a machine within your network communicating to IP address within this range, does this look suspicious to you? Like for me, before I learned about the proactive use of cloud services, I would say no. It's a Microsoft, right? We have a bunch of Windows machines. They're probably talking to some of the Microsoft infrastructure. We are based in Asia. The closest, one of the closest data centers in Asia is in Singapore. This is IP range that is assigned to Microsoft data center in Singapore. What's wrong with that, right? But what you would not realize is that um, the Microsoft cloud offering, the same as with Google, uh, allows you to create free try-only instances of virtual machines, and you could play around with them. A, without paying. B, like what we've seen attackers, if they find credit cards which they could reuse, they could do it fully anonymously. So the only thing it requires is the registration of a credit card. So, and we've seen that attackers like very intensively using and abusing this. So we've seen exfiltration tools, and exfiltration tools. We've seen exfiltration tools which tailor to all of the cloud platforms out there. So they might support Microsoft OneDrive, Google Drive for exfiltration, Dropbox for exfiltration. We've also seen tools which would use cloud services for both C2 communication and data exfiltration. Like in this example, it's a communication pattern of raccoon stealer malware, which has been quite widely deployed in some regions recently. It's one of the popular tools which some of the threat actors are using. So if you carefully look at this, is the on the top of the screen. This is a screenshot from Sandbox. You can actually see that it talks to Google IP addresses, and the Sandbox whitelist those IP addresses. So even Sandbox whitelist IP addresses owned by Google. But the way this particular communication pattern was implemented, the guy would store a file within a Google Drive. So the file name would contain a base 64 encrypted string, which would encrypt IP address of the C2 machine that he would be talking to. The C2 machine itself was deployed on Google Cloud, just a regular machine, and he wrote his front-end C2 communication in, I think it was written in PHP, yes. It was written in PHP, and this would basically proxy the request forward to the actual machine where he would be collecting information. So from an organizational or like incident response point of view, you see this traffic happening on your machine. It might be going over HTTPS. In this particular case, it's going over HTTP, which might make detection a little bit easier, but you could easily just deploy HTTPS as well. And you just see traffic floating to Google data center back and forth. And you think it's probably normal, like people use Chrome, people use other Google products. So it should not be unusual, but in fact, it is. And we also have seen attackers deploying stuff on Google's App Engine as well, and they pick up domain names which are very similar to the domain names which Chrome browser itself would be using for some of its communication. So it might be really hard to find their activities if you don't have specific patterns. So we actually did a breakdown of our C2 database by ASN. It's a breakdown for like only 2 months of what are the most popular owners of the C2 IP addresses, and you can see that Amazon and Google, like the obvious leaders in the cloud technology, they're also taking the top spot here as well. Zoom in just if you want to see more details. So with this, let's see what the cloud technologies look in the underground. So they are very popular. There are lots of tutorials, lots of buy and sell activities on like a bunch of forums. There are also people like offering tutorials how to create a bunch of free Google instances. So basically, they're looking for Gmail accounts with bound credit cards, because both Google and Amazon Azure, they simply require credit card for verification. What I think they probably don't well, or they do realize, but it's a trade-off, is that a credit card might be stolen. Uh, in some cases, it might be an anonymous credit card. Uh, I believe Google is blacklisting some of the cards, like as this guy is explaining here. So they basically hunt for accounts was bound credit cards, and out of this they could create free Google Cloud instances which they would use. So in the case of Raccoon, I believe that's exactly what happened. I don't think the guy actually owns a credit card or an account under which the Google Cloud instance was created. And there are shops, like if you don't want to, like if you're an underground threat actor and you don't want to spend your time on bothering creating those cloud instances yourself, there are shops where you can just order them online as you go. So if you create a successful operation with a Raccoon stealer and you continuously need a new intake of Google Cloud instances, because once they've been around for a while, they obviously will get reported, they will be taken down, so you'll need a stream of them. There are shop fixes where you can simply buy them, and they're not expensive. Like the price here is listed in rubles, and given a recent fall of the ruble because of the oil prices, it's probably roughly like what, $10 or $1. Yeah, well, $1, 80 rubles. So I think it's extremely cheap, extremely affordable. So if you were running this operation, that's your expenses. And of course, there are also people who just selling accounts, AWS accounts, Azure accounts. So all of the operations from which we've seen as incident responders, that we've seen malware using Amazon Azure as CPU, we've seen malware using Google Cloud as CPU. We can confirm this activity also by observing activities on the ground market as well. People buy, sell those accounts. Since we see those buys and sells on semi-open forums, on the hidden forums, like we believe there's quite a bit of activity. And the prices are also like very, very, very affordable. In many cases, when you buy instances, they also offer money-back guarantee. So you buy an instance, they can guarantee that this instance will run for a day at least. If the instance goes down, they will provide you a replacement free of charge. And of course, you could still use all of those really cool Amazon tools like CloudFormation, deployment scripts to deploy your CPU. So deploying CPU will be like very fast. There are also other small clouds which, like, some of us probably were not even aware of. For example, Dropbox is trying to get into the web hosting business, and they have this platform called Kisser, which is tailored to provide simple web hosting. And we've seen lots of phishing websites basically using this as a platform. So there are lots of abuse happening on cloud platforms. And I believe criminals actually realize how useful cloud platforms are to them before the actual proper customer could pick up this tool. And I think I'm more or less done with my presentation, and I'll leave some time for question and answers and some time to switch to the next speaker. But on the last note, remember we were saying a cloud is just someone else's computer, right? So who is the most like proactive user of the cloud technologies? We did a case study on hostings of some of the underground forums, and we actually have a winner for this. So one of the underground forums called Skyfraud .ru, I think, if I'm not mistaken. So we visualized how it's used IP addresses over time, like for a period of 2 years, and you can see that this guy load balances or the threat actor which runs this forum load balances the front end proxies of his forum through like a massive amount of assets. So he runs his code on a bunch of someone else's computers, and in my opinion, this makes him a notable cloud user. So that's the winner in our session. And with this, I hope you're not as depressed on cloud technologies as we are. I did this sketch to illustrate actually lockdown. That's what people do when the city is in lockdown. They get depressed and they drink wine. So that's the picture. With this, I think I have about 10 minutes to take questions, and there will be some time to switch to the next speaker. Yep.
At the moment, there aren't any questions on Slido, so seems that at least over there, people are very content with your talk and your explanation.
Cool. Awesome. Then it was my great pleasure sharing our experience on the cloud stuff. Apologize for the cat sounds next to me. I fed them just before the presentation, but apparently they still are not happy. So with this, it was my pleasure presenting, and thank you very much.
Thank you, Fyodor.